All right, let's do number 14. This one's kind of interesting because we have this weird statement as the conclusion. If R or R, then not P. Now, we should notice that we're trying to prove a conditional, so a good strategy would be to use conditional proof. If we use conditional proof, we're going to want to assume the left side of the arrow, R or R, and then we're going to try to get not P at the bottom, which then will allow us to write after the box, write our if R or R, that leads us to not P. So then not P by conditional proof. So we assume this, and somehow we need to get not P. So let's try to do that strategy. We'll assume for conditional proof R or R, and we're going to try to get not P. How are we going to get not P? Well, we have a not P in our premise right there, and I'm thinking about disjunctive syllogism, right? That's the one where, let's see, disjunctive syllogism, that's this one right here. That says if you have a disjunction and you negate one side of it, then you can conclude with the other side. It doesn't matter which side that you negate, but you're going to end up with the opposite side. So let's try that. So we could put on our wish list over here that we would like to get the negation of the other side of the disjunction, which is going to be not, and then Q and not R. So that's what we would like to get, so we could use disjunctive syllogism to get not P. How can we get this from what we have so far? Well, one helpful thing is to think about what's equivalent to what we need to get. Because sometimes what's equivalent to what we need to get is easier to get. So hopefully you thought of De Morgan's, because you have a conjunction inside of these parentheses that's negated. So hopefully that reminds you of De Morgan's. If we use De Morgan's, that would be not Q, we distribute the not, then we flip the dot to a V, and we apply the not to the not R, so we have two nots, so we get this. So now we have not Q or not R, sorry, not Q or not R. And of course, you see double negations, you should of course know that by double negation, that's going to be the same as this without the two negations. So is there a way for us to get this? We have R or R, and of course that the rule that should jump out at you is redundancy, right? R or R is going to be equivalent to just R by itself, right? We have R by itself, and we want to get a disjunction that includes R. We can, of course, just add anything we want by the rule of addition. So 3 addition, we can just add the not Q. Let's add it to the left of the R, so it's already in the correct order that we're going to need to use it with this. So now we've added the or not Q, and now we can work forwards through the process that we just thought through backwards. So from not Q or R, we can then use double negation to get this, not Q or not R. It's going to be 4 double negation. And then from this, we're going to get this by De Morgan's. So 5 De Morgan's is going to give us not Q and not R, right? And now we have the negation of the right side of this disjunction. So we could use 1 and 6 with disjunctive syllogism. And that's going to give us not P. So we followed our strategy and got not P. Inside our imaginary world, we've shown that if we assume R or R, that leads to not P. So we can write the corresponding conditional. R or R, if R or R, then not P. And that's going to be from 2 through 7, conditional proof. Right? There we go. Awesome.